Good day, good morning. It's afternoon when I'm recording this. This will be our intro for day 7 on the notes from the data section. I do have a warm up here. As you can see, I've switched off of a notepad art or drawing, and I've gone back to my document camera. There was a lot of stuff uh, that we needed to do, and I wasn't comfortable with all the things I need to do for all my classes. So I'm just going to go back to the document camera and hope this works out for you guys. Okay, so this is the warm up for today. It says the distribution of high school girls' elbow to middle fingertip lengths is approximately normal, with a mean of 34 centimeters and a standard deviation of 3 centimeters. Draw and label the curve with notations at the mean, plus and minus 1 standard deviation, and plus or minus 2 standard deviations. And then after that, what percent of high school girls have an elbow to fingertip length between 34 and 37 centimeters, between 28 and 37 centimeters, and more than 37 centimeters? Would you please pause the video at this point and do your best to try those problems, and we'll work through those after the break. Okay, so I'm assuming that you've already tried these problems. A couple other things that we're going to need before we go on to the rest of the lesson. I need you guys to access your the sheets that you guys have with the standard normal distribution on it. This should have been the last page of your notes from the data unit. There's 2 sides to it. We'll need to access both of those. We'll also need to access your standard normal distribution notes for day 7. I'm going to be going over those, and they'll be attached. They should be attached to the Google Classroom assignment that this video is also attached to. So if you don't have those, you can print them out. You can reference them. You should have them. But first, let's go through this warm-up. Draw and label the curve. It's at approximately normal, so this is a normal distribution. So we're going to have our normal distribution curve. It's symmetric, and like so. Always in the mean at the top, or the mean's at the top in the middle. There's the mean, and that mean is going to be at 34 centimeters. So I'm going to put a 34 right here. Something we didn't talk about on the previous video, there's an inflection point where it stops going down and starts coming back up. It's right about there. Okay, that's where the first standard deviation is. And so from the curves from now on, go ahead and make that where the first standard deviation is. That should be 3 centimeters more than 34, so that's 37. The same width is 1 standard deviation between these two. Try to make the same width on the other side of the curve as well, and that will be 34 minus 3, which would be 31. So that's where the first standard deviations are. Go ahead and make about that same width to me the second standard deviation. That would be up at 40. That's 37 plus another 3. And then the 31 minus the 3, that should be 28. Okay, so if we remember, the mean is 34. Between these 2 pins is 1 standard deviation left and right. We're saying that 68% of the data is between the 2 pins. So if we had the sample or the population, actually the population of the girl's fingertip to elbow length in centimeters, 68% of the young ladies would have a fingertip length between 31 and 37. And then that's 2 standard deviations now. I've opened it up to 2 standard deviations. So now that's 95% between 28 and 40. Okay, so I'm going to go ahead and put the individuals. Remember, between 31 and 37 is 68%. So in this band, there's 34, and this band, there's 34. The 34 and 34 is a total of 68. And then between two standard deviations from here and here is 95. 68 minus 95, or 95 minus 68, is 27. And so these two split 27%. So that'll be 13.5% here and 13.5% here. And then what we have there is 95% between the two. So now it's 5% outside of that. 5% into two different tails is 2.5%. Okay. Now we can go ahead and answer those questions. What percent of high school girls have an elbow to fingertip length between 34 and 37? Between 34 and 37, is that 34%? Between 28 and 37 centimeters, so that's 28 and 37. Well, it's the entire 31 and between 31 and 37, which would be 68. So we know it's that 68, and then plus the 13 and a half. Oh, so between 31 and 37 is 34 and 34, that's 68, and then another 13.5%. I believe that's 81.5%. And then more than 37%, more than 37% would be here on up. So that'd be 13.5% plus 2.5%. That would be 16%. Again, that's 13.5 plus 2.5. So 16%. So that's when the numbers work out perfectly. We have these answers between 27 and 30, or 28 and 37, between 34 and 37. Those are exactly where the first and the second standard deviations end. Of course, we have to be more flexible. We have to be able to say, for example, what happens if we want to go between 32 inches or 32 centimeters and 35 centimeters? What percentage is that? Well, we have to have another way to do that. And that's where the table that we have comes in. So take a look at your table now. And I'm on the positive z-scores at this point. There's a positive side and there's a negative side, okay? These numbers in here are probabilities. They're also areas, if you want to think of it that way. It's the area to the left of a z-score on a normal distribution. So if we find a way to locate where a particular number is on the distribution, we can assign to it a z-score. Okay, now what the heck is a z-score? Well, now we have to go back to our notes. So we're done with the warm-up. Let's go back to our notes. Again, this is the day 7 standard normal distribution notes. Okay, the standard normal distribution is just like any other normal distribution, except its middle is always 0. And then the standard deviation is 1. So if I go up 1, that's where my inflection point is. Okay, and that's 34%. What this really is it shows you a normal distribution, and the numbers on the bottom are the numbers of standard deviations away from the mean. This is one standard deviation above the mean. This would locate 2 standard deviations above the mean. And then this would be 1 standard deviation below the mean. Okay, so the same percentage we just went over in the warm-up are still there. Okay, we want to convert all kinds of our scores, and this is what we're going to be doing the next couple days. We're going to convert all of our scores to what's called a z-score. The standard scores are more commonly called z-scores. These are, to use the standard normal distribution, we'll be converting raw scores into standard scores. Okay, and the standard scores are z-scores. So we have a little formula that we convert, really easy to do, and we'll talk about that tomorrow. And then we're going to locate places on the normal distribution and assign them a z-score. The z-score is going to let us know the percentages that we're looking for in the problems that we have already done. So the z-score is simply the number of standard deviations below or above the mean. We've just kind of gone through that. Okay, so what we want to do is take a look at this first problem. The area to the left is the key on the table that we're going to be talking about. This first one says to use the standard normal table to find each probability. So we've got z is less than 1.43. What we want to do is we want to locate where 1.43 is. 1.43 is right about here. And what we want to do, I'm going to zoom in here real quick. What we want to do is we want to get the area less than that, because that's what this said. We want the probability of having a z-score less than 1.43. Well, these are the z-scores in the bottom. Okay, so I want a probability of z being less than 1.43. So I need to figure out the area. Well, the table lets me know that. So let's take a look at the positive table. Again, we're looking for a z-score of 1.43. So let's go down. Remember, these are the z-scores. And I've got a z-score all the way down to here. There's 1.4. If I wanted 1.40, I'd go to this first column. If I wanted 1.41, I would go to the second column. Notice the 0.01 here. That 1 is just added on to the 1.4. So that'd be 1.41, 1.42, 1.43 is right here, 0.92364. I'm going to write that on the other piece of paper, 0.92364. So that is a z-score of 1.43, and now a probability of, I've lost my mind already. Hold on. 0.92364. What that means is 92% and some change of the area under this curve is to the left of that mark. 92%. But that percent means it's a probability is too. So the probability that my z-score is less than 1.43 is 0.92364. With that, try to do number one. Pause your video and try to do number one, and we'll be back in just a second. Okay, hopefully you've paused and you've tried to do number one. 2.08, but negative. 2.08 is going to be way over here, okay? So I'm going to put a z-score right there. Z equals negative 2.08. And the table is going to show us all the area to the left of that point. And so it's a very small area of the tail. We should have a very small number here. So to get that probability, we're going to go to the negative side of the standard normal page. See the negative z-scores here. And we're going to go to negative 2.0. So there we are. And we're going to go all the way across to the 8th column. You see the 0.08 up here. It's not as clear, but it's there. And 0.01876. 0.01876. So what that says is, if you have a z-score of negative 2.08, that means the area to the left of that point on the curve is 0.0876. So 1%, 1.8% of the area is to the left of that curve. And that's right, 1% is actually closer to 2%. 2% of the area underneath that curve is to the left of that point. So again, the probability that my z-score is less than 2.08 and negative is 0.01876. When we put these into context, when we have a problem like we did with the fingertip lengths, this will make a little more sense. In fact, I'm going to do that one right now. This is a little primer for tomorrow. The z-score that you always have is the score that you actually have minus your standard deviation. Excuse me, what am I saying? Try again. It's the score that you have minus the mean divided by your standard deviation. So here's a problem. This is the fingertip length distribution where it said that the mean was 34 and the standard deviation was 3. You might also see this as mu. You might also see this as sigma. Okay? And so that makes this formula x minus mu over sigma. So you might see it both ways. Okay. So I want to know what's the probability of a high school girl having a fingertip to elbow, FT to E, fingertip to elbow length less than, let's say 35. Well, if I draw that curve again, I know that 34 is going to be right here. That's going to be in the mean. I'm going to estimate that 35 is right here. What I want is I want the area to the left of that. I want the area to the left of 35. But I don't have a z-score. I don't know how many standard deviations 35 is compared to 34. I have no idea how much more than the mean of that is. I will tell you, though, that to the left of 34 is 50%. And so to the left of 35 is going to have to be more than 50%. So let's find our z-score for 35. So my z-score for 35 is going to be my x. Well, the x I'm talking about is 35. So that's the data we've been given. The mean for this distribution is 34, and the standard deviation is 3. So my z-score is going to be 1/3, which is 0.33 repeating. And we're going to round that off to its nearest 2 places, 0.033. So pretty simple formula. We'll use a calculator on a lot of these computations if we need to. But I got that pretty easily. Now I need the percentage or the probability. And this basically goes back to the page we're doing. What's the probability that my z-score of 0.33 repeating okay? So let's go to our table. It's a positive z, 0.33 repeating is going to be 0.3 and then 3. I can't go any farther than that. I don't have the 0.33 repeating. We just have to go to 2 decimal places. So 0.62930. 0.62930. So in context, when I ask the question, what is the probability of a high school girl having a fingertip to elbow length less than 35 centimeters? It is 0.629. That basically says 62.9% of high school girls have a fingertip to elbow length less than 35 centimeters. So that's kind of the whole process. So now when you were just finding the z-scores and converting them to the percentages, this is what the full problem is going to look like in a day or so. Let's go back to today's notes. And now let's figure out what to do with this next problem. Remember, the area on the curve is to the left of a particular z-score. And now I want the probability of a z-score being greater than something. That's going to be the area to the right. Let's locate that z-score on our graph anyway. I think it's going to be right there, negative 0.67. That's going to be between 0 and negative 1. So this is my z-score equaling negative 0.67, 0.67, right there. If I look on the graph, or excuse me, on the table's going to tell me this area that I've done in red. But I don't want that area. I want all the area that's in black. Well, you remember probabilities have to add up to 1. So the area that's in the red plus the area that's in the black has to add up to 1. And so what I'm going to do is I'm going to find the area of the red and I subtract it from 1. So the probability that z is greater than negative 0.67 is going to equal 1 minus the probability of z being less than 0.67. And I got to put negative in there. Okay? So what I'm going to do is I'm going to find the area in red. The area in red is this right here. Just underlined it in red. Hopefully you can see that. I'm going to find that area, and then I'm going to subtract it from the entire curve. The entire curve is probability of 1. I subtract this area off from it, and I'm going to have left the area in black, and that's what I'm looking for. So let's go on our table. Let's find a negative z-score, 0.67, and let's negative 0.67, and let's figure that out. So down here at the bottom, negative 0.6. Then I have to go over to 7. I believe that is 0.25143. This is 0, 1, 2, 3, 4, 5, 6, 7. Yep. And on the table, you can see it above, 0.25143. 0.25143. Got to do that subtraction. If you want to do it on a calculator, you can do it by hand. You can probably hear me opening the calculator in the background. So I am going to do it by calculator. 0.74857. 0.74857. So that is the probability that z is greater than negative 0.67. So you have a z-score of negative 0.67. If you want the area that's greater than that, well, it's going to be this probability, 0.74857. So that's what this is, 0.74857. The red area was what we found here, 0.25143. If you add those up, that equals 1. And that, of course, we are looking for the area to the right of that z-score. Pause the video, please, work on number 2, and we'll get going on it in just a second. This is the exact same problem as it was the other one, with just a little different number for z. First of all, locate your z-score. Z is greater than 1.02, just barely more than this one right here. Okay? We want this area. That's a z-score that equals 1.02. I want the area that's to the right of that because I want the area that's greater. Okay? So what I'm going to do is I'm going to figure out this area from the table. So the probability that my z-score is greater than 1.02 is going to equal 1 minus, because that's the entire curve is 1, minus the red area, which is the probability of z being less than 1.02. Look at on the table, 0.1, 0.02, look at the positive z-scores. 1.0 is here, 0.84614. 0.841, I already lost it, 1.02, 84614. Okay. That is it, 0.84614. And if you look at that curve, it should make sense. 84% is almost all of that curve. There's only 16% of that curve less than or not in the red there. And that makes sense. The vast majority of the curve is to the left of that black line there. So we want the area that's in front of that line or more than that line. So we'd go ahead and do this subtraction. It's going to be 15%, almost 16. 0.15386. 0.15386. That's the probability that my z-score is going to be greater than 1.02. Awesome. Next problem. The third type of problem is now you're going to be finding the area in between two values. Okay? Where we want the z-score in between negative 0.226 and 2.04. So negative 0.226 is right here. That's a z-score of negative 2.26. And then this is 2.04 up here. Okay. So we have this area here. That's a solid black. And we have this area right here, which will be everything to the left of this. So what I want to do is I want to get the area between the two lines that I've drawn. Well, this one will do all of the area and this section. What I want to do is I want to have just this area to the left here, but take this area off. So to get the probability of having a z-score between negative 2.26 and 2.04, I'm going to have to first find the probability that my z is less than 2.04. That's everything from the left to the left of this, the pen right now. That's everything. That's all of the curve to the left. And I'm going to subtract off the area that's solid black, and that's a z-score less than negative 2.26. So again, what I want is what I've got shaded in red, only between those two lines. So I'm going to take the entire area and I'm going to subtract off the smaller area. And that'll give me what's in between or shaded in red. Okay, so I'm going to find two different z-scores. Z of 2.04 0.97932. And that should make sense. All of the curve to the left of this line is 97 or 98 point, or about 98% of the curve. So very little in front of the curve, or in front of that line. Everything behind it is about 98%. Then I'm going to subtract off a z-score of negative 2.26. Negative 2.26 is 0.01191. 0.01191. Okay, and that's here. That's just that little sliver of the curve that was solidly black. That's 1% of the curve. Go ahead and do that calculation real quick. 0.97932 minus 0.01191. 0.96741. That's the area that's in red. That was the area that was shaded red to begin with. Okay, pause the video, try number 3 on your own, please. Watch of course, go back and watch the example, what I just did. Go through that again if you didn't quite catch it. Try number 3 on your own, please. Hopefully you've tried number 3. I'll do it kind of quickly here. 1.33 is right about here, and 0.97 is right about here. So we are only looking for the area between these two. So I'm going to take the probability that my z-score is just between those two values that are really close together. There'll be the probability of the farthest one, That's a z-score of 1.33. I'll be doing that one, probability that my z is less than 1.33. And I'll be subtracting off the probability that my z-score is 0.97. That one's there, that one's there. So 0.97 is this way, 1.33 is this way as well, but also including the red. So if I want the area that's just in the red, subtract off the 2. Z-score of 1.33. .90824. Now the z-score for the 0.97 should be less than that. And it is by a little bit, 0.83398. So 0.90824 minus 0.83398, 0.07426. So that means the area that's in the red is only 7.5-ish% of the total area of the curve. So the probability that you'd end up with a z-score between 0.97 and 1.33 is the same probability, 0.07426. Hopefully you got this lesson. Go ahead and try the homework now. Please rewatch whatever parts of the video that you didn't catch. And I will see you next time.